Today we are going to solve quadratic equations by graphing. To begin with, you have to realize that in the previous chapter we solved by factoring. On the left-hand side you see the quadratic equation x squared minus 6x plus 5, and it is factored into x minus 5 and x minus 1. Those two factors set equal to 0 show us that the solutions are 5 and 1 for that quadratic equation. We can also solve this same quadratic equation by graphing. On the right-hand side, you can see that I have graphed the equation, and we learned how to do that in the previous section, just graphing an equation. But we can see that this parabola crosses the x-axis in two places. Those x-intercepts are 1 and 5. And lo and behold, those happen to also be our solutions. X-intercepts are the solutions of the parabola. When we solve by graphing, we need to, 1, write the equation in standard form. Make sure that you have 0 on one side. 2, graph the function. And then number 3, the x-intercepts are our solutions, or they can also be called roots, and they can also be called zeros. Please note that not all quadratic equations have two solutions. If it crosses the x-axis twice, there are two solutions, thus two x-intercepts. If the quadratic equation touches the x-axis once, that's where the vertex is touching the x-axis, then there is only one solution, one x-intercept. And sometimes our quadratic equation does not touch the x-axis at all, and we say that that quadratic equation has no real solution, no x-intercepts. We are going to solve this equation graphing by hand first to show you how things work. First of all, move your 5 over to the other side so that you have 0 on your right-hand side. Then we find our axis of symmetry, the x-coordinate of our vertex, negative b over 2a. So we find out that x is equal to negative 2, and we're going to set up then our xy table. When we set up our xy table, x is across the top, y is on the bottom, and our vertex we're going to set in the middle. The negative 2 is going to go on the top shelf, and we will substitute the negative 2 back into the equation for x and find our corresponding y. When we do so, we find that that is negative 9. We're going to plot that point on our graph. Then we will choose numbers on our x-axis that are equidistant from the vertex. I have chosen the numbers negative 3 and negative 1. I then need to find the corresponding y values for those two numbers. The corresponding y values should be the same if you've chosen your x values correct and your vertex is in the right spot. I found negative 8 for both of mine, and I've plotted both of the dots. It's wonderful that this is starting to open up because I see that I have a quadratic equation with a positive leading coefficient, which tells me it opens up. I will cross the x-axis in two places. I'm now going to choose two more x's, and I chose negative 4 and 0, and we'll find our corresponding y's. Corresponding y's are negative 5, and so I'm plotting those two dots. I'm getting closer to the x-axis. I have to keep going because I got to go up and actually hit the x-axis. I choose two more x's, negative 5 and 1, and they hit the x-axis. I can tell that they do because my y is 0. I want my y to be 0. I'm going to draw my parabola through those. My y being 0 means that the x's there are my x-intercepts. I have found the solutions to my problem, and I will write my answer as x equals negative 5, 1. Showing all of this, the xy table, the graph, my answer being negative 5, 1, shows that I graphed this by hand. Now we're going to graph that same equation with the graphing calculator. Please pick up your graphing calculator and turn it on. We are going to start with plugging in our equation. Make sure that you've pressed y equals and type in your equation, x squared plus 4x minus 5. When you press graph, you should see this graph on your graphing calculator. When I press second graph, I see the xy table. I can find my xy pairs that I will need to be writing down on my paper when I'm actually doing my homework. You should see that right here I can see my vertex because it is the only one between, if you notice, I have y's that are exactly the same here. I have y's that are exactly the same here. And this number in the middle here is my vertex. And you notice where my y is 0 here, that tells me that this number and this number are my solutions in my xy table. How very cool. I can also find those by pressing second trace, gets you to this screen. Then we are going to press 2 to go to our zeros. And when we press that 2, we will get this screen, and we see that it says left bound down in the bottom left-hand corner. You want to use your left arrow now in order to move this little blinky light that is down here. We want to get that up in this area. So we're going to press the left arrow to go that direction. When you do, you get the blinky light right up here, and please press enter so that now you've set the left boundary in finding our x-intercept over on this side. Once you've pressed enter, that now asks us to start finding the right boundary. And so now we're going to use our right arrow so that we can start moving this blinky light down to below the x-axis. Once I have moved my arrow down below, you notice I have mine down here, I'm going to press enter in order to set my right boundary. Once I've set my right boundary, I see that I have the word guess down here. I don't care about that guessed. I am going to press enter one more time, and now I see that my 0 is x equal to negative 5. This is as close to the y-axis as I can get, or excuse me, not y-axis, but y being 0 as I can get. So my x here is one of my zeros where it's crossing the x-axis, the x-intercept. We need to find our other x-intercept, so in order to find that, press second, trace, and then 2 for the 0, and that gets you to the screen again. And this time we're going to use our right arrow so that we can move this blinky light over to this direction so that we're just below the x-axis. Once we are below the x-axis, we're going to press enter so that we've set that left boundary. And now we're going to press the right arrow so that we can start moving our little blinky light above the x-axis to get to the right-hand side of where this intercept is. So when I press that right arrow, that gets me above here, and I want to press enter in order to set that right boundary. Once I've set that, I see the word guess. Again, I don't care about the guess. I'm going to press enter to get past that. And now I see my 0 is x equals 1, and that is the 0 on the right-hand side. I now have both of my zeros. Notice how y is equal to 0 here, but my 0 is x equals 1. We're going to use the graphing calculator in order to solve this particular equation. You see that you have the height of a soccer ball after it's kicked can be modeled by the graph of y equals negative 0.04x squared plus 1.2x, where x is the horizontal distance in feet that the ball travels. The ball's not touched. It lands on the ground. We want to find the distance the ball was kicked. So what we're really doing here is we're taking a ball, it's getting kicked, it's going over, and we want to find how far the ball had to travel in order to land on the ground. Plug that equation into your graphing calculator and use your XY table, use your tracing function in order to find where the ball lands on the ground. You might need to change your window on your graphing calculator in order to make the X go out far enough to see it. Good luck. All right. If you stopped the video for just a moment, you would have found that your XY table started at 0, 0. Actually, it did negatives too, but we only care about the 0, 0. And it goes all the way out to 30 on the X value before you get a Y equal to 0. Your vertex is at 15, 9. We actually know that the ball only goes up 9 feet in the air. So we actually know that our max on this problem is going to be equal to 9 feet. Okay, that's a little extra piece of information for you there. But what we do also know is that our ball goes out 30 feet before it hits the ground. What I expect to see on your assignment, I expect to see an XY table with a vertex plus 4 more points from your graphing calculator. Graph those points on your paper grid and then write your answer as x equals whatever your x-intercepts are. If there is no x-intercept, because it doesn't touch the x-axis, you would write no solution. There are many ways to solve quadratic equations. Proof that you graphed is actually showing the graph. Good luck on your graphing, and I'll see you next time.